Okay, so we have finished the Bronsted-Lowry acid base and Arrhenius and kinetics and the association dissociation constants and conjugate base pair, etc. The nice things we have finished on the acid base. Okay, now let's define the third one, which is the Lewis acid base theory. Okay, so all of the acid base are not covered by Arrhenius. Then similarly the Bronsted-Lowry was the improvement over the Arrhenius, and Bronsted-Lowry also couldn't define all of them, and Lewis acid base theory is perfectly works for the remaining acid and bases which are not described earlier. So what the Lewis acid base theory says that, so all positively charged species, all polyatomic cations, neutral species, those are electron deficient species due to the vacant orbital. According to the Lewis, all are the Lewis acid base reactions. Such are the all are the Lewis acid base reactions. So bases, the species that can donate electron. So the acid is that can accept electron, that can accept electron. Base that can donate electron, because the base are minus, right? They have additional electron and they can donate their electron. So that's the Lewis acid base theory. So, and all positively charged species, for example these, because they can accept electron, right? For example sodium plus, copper 2 plus, they all can accept electron, all positives, positively charged species. And the neutral species, those are electron deficient because of the vacant orbital. For example BF3, SnCl4, AlCl3, etc. According to rules, they all are the Lewis acids. So base, the species that can donate the electron. For example, all negatively charged species are bases. Every negative, Cl minus base, OH minus base, HSO4 minus base, SO4 2 minus base, all of them are. And that, so all species that have a lone pair, if something has a lone pair, they are also base. For example NS3, it has a lone pair, so it's a base, H2O, right? So that is, and alcohol, sorry, ROH, lone pair, ROS, that's why it is also base, alcohols are base. So these all are the bases. Okay, so nickel has vacant d orbital, electron configuration is D8. This also can make the coordinate bond and make ligands, right? So these are the acid and bases definition of the Lewis. Electron accept acid, electron deficient, sorry, electron can donate base. So now let's say acid ionization constant. Okay, Ka for acetic acid, for example, is this 1.8. Ka we already have studied, Ka, Kb, right? Because the acid ionization constant for weak acids are numbers with negative exponent, right? We commonly express acid strength pKa. So the acid strength, we instead of Ka, we will measure the strength by pKa, which is equals to minus log of Ka. Because look at the weak acid at 10 to the power minus 8, 10 to the power minus 5, these numbers, right? So let's define the new, which is the pKa. So where the value of pKa for acetic acid, pKa is equal to minus log Ka. For acetic acid is 4.75. Value of Ka and pKa for some weak acid is in the table 8.3. We will see that table. Okay, as you study the entries in this table, note that the inverse relationship between values of Ka and pKa. Ka increases, pKa will decrease because the minus log of Ka. We will see that. Okay, now okay, look at that. Ka 7.5 10 to the minus 3, pKa is 2.3. Formic acid, Ka is 1.8 10 to the minus 4, 3.7. They see that 2.2 times 10 to the power minus 13, SpO4 2 minus 22 pKa. So what is happening actually, less is the, so pKa, K more is the Ka, stronger is acid, and the less is the pKa, stronger is acid. So see that increasing strength. This is weakest in this list. In this list, HPO4 2 minus is weakest. It's 22.66 pKa equal to. In this list, H3PO4 is phosphoric acid, the strongest in this list. It's not the strong acid, but the strongest in this list. Okay, that is 2.12. So small is the pKa, stronger is the acid. That we understand from this, right? Because the Ka, more is the Ka, more is the stronger is the acid. So that's why the less is pKa, because pKa is negative of the logarithm. So that's why, of course, the smaller is stronger. So now property of acid base. Now let's say study some property of acid base. First of all, neutralization, right? Acid base reaction, they have one property, they have a neutralization reaction. Okay, acid and the bases react with each other in process called neutralization. Acid plus base. This process is thought to be the neutralization, because this gives a salt which is neutral plus water. Okay, so that's why it is a neutralization. So these reactions are discussed in section 8.6. we will discuss there. So reaction with metals. Now strong acid reacts with certain metals called active metals to produce a salt and a hydrogen gas. Okay, acid property is acid react with metal, some, not all metals, okay guys, some metals, and that gives you salt, metal salt plus H2 gas. For example, HCl plus zinc, very important example, ZnCl2 plus H2 gas. So that is another. So neutralization reaction, the acid base reaction produce salt and water. So some acid react with metal and produce hydrogen, that is another. Reaction of a strong acid with a metal is a redox reaction. Okay, so acid plus metal, this is not the acid base, right? This is the redox reaction. Redox reaction. Okay, for example, Mg plus 2H plus gives you Mg2 plus H2, right? So look at that. Magnesium is oxidizing and hydrogen is reducing. So because this oxidation number decreases, right? So reducing, this is oxidizing. Okay, so that is not the acid base reaction, that is not the neutralization, that is the redox reaction. Acid and metal redox reaction, that is. So now let's see this very important activity series. In this series tells us that whatever is the upper, that can reduce whatever is the below. So for example, lithium can reduce everything. For example, lithium plus K2SO4, suppose if you do that, it will give you 2K plus LiSO4. Okay, Li2SO4. 2. So look at that, it's reducing that because K2, lithium has 0 here, oxidation number. So here is not 0, right? Minus 2, Li2 means the 2x minus 2, so it is a plus 1, right? 0 to plus 1. Potassium is 2K, plus 1 to 0. So it's reducing the potassium, right? So lithium can reduce all. So look at that. Weakly reducing, they are weakly reducing. Copper, silver, gold, they are weakly reducing. As go up, they are strongly reducing. They are strongly. These metals react rapidly with the aqueous H3O plus ions. These metals, which ones? So lithium to the whatever given here, lithium to the lead. These can react with the H plus vigorously. giving the S2 gas. These all lithium plus that the H3O means the acid, right? Lithium plus acid give you hydrogen gas. So they all reduce if the upper one can reduce the below one. That this is a metal activity series. So now again reaction with metal hydroxide. Previously we studied the reaction with metal, so that is the reduction reaction, right? Now let us see the reaction with the hydroxides. So reaction with metal hydroxides. A reaction of an acid with a metal hydroxide gives us salt plus water. For example, HCl plus potassium hydroxide. It will give you H2O plus KCl. The reaction is more accurately written as like that, right? H3O. This is HCl can be written as what? H3O plus Cl minus, right? Plus this can be written as what? K plus OH minus. So the net ionic equation we have to write. This is the molecular equation, right? And this can be written as H2O, because it's a liquid, we cannot separate that, plus K plus Cl minus, right? Now first of all, let's balance that. Okay guys, this is balancing. If you balance, that's fine, right? So chlorine cancel, spectra ion, right? Look at that, and then what will be H3O plus OS minus, this gives you 2S2. Done. So this way we can have the net ionic or total ionic equation also in this case. Again same thing, strong acid react with metal oxide to give the water plus salt. It's the same thing, water plus salt. Okay, so that's fine. Now let's see again, stronger acid react with carbonates to give the carbonic acid, which rapidly decomposes to carbon dioxide and H2O. So stronger acid, so carbonate, okay, 2S3O plus, this is stronger acid, CO3 2 minus gives you H2CO3 plus 2H2O. But H2CO3 carbonic acid, that rapidly gives you CO2 plus H2O. So overall reaction will be, this cancels, 2S3O plus CO3 2 minus gives you 2S2O 3S2O plus CO2 gas. Okay, and again a strong acid reacts similarly with the bicarbonates also. Look, see that strong acid if react with the carbonates, calcium carbonate, magnesium carbonate, like that, if the carbonate, it gives the carbon dioxide and water. Similarly, if strong acid react with the bicarbonate, again it gives the same thing. So for example, strong acid is H3O plus, right? Acid means hydronium ion. All are aqueous. Okay guys, plus we are reacting with the bicarbonate, SCO3 minus. This is aqueous. So this gives you again H2CO3, same thing, plus H2O, and H2CO3, right? Aqueous will give you CO2 plus H2O. So cancels. So H3O plus aqueous plus HCO3 minus aqueous gives you CO2 plus 2H2. Done. So now finally let's see this. Okay, so now what it does with the ammonia. So the strong acid, any acid stronger than NH4 plus is stronger enough to react with NH3. Okay, any acid which is stronger than NH4 plus, it should be stronger than NH4 plus. If it is weaker than NH4 plus, no. So enough to react with NH3 to give us salt. Okay, for example HCl, of course it is stronger, plus NH3 all are aqueous. Okay guys, I am not writing aqueous here, that's why remember this aqueous means by default if it is soluble in water. So NH4 plus aqueous plus Cl minus, done. So this is, so let's see another one. For example, methylamine, see, methylamine ion plus chlorine minus. So this is the reaction with the ammonia if it is stronger. So far I would like to stop it today. We will continue the chapter in the next videos, next couple of videos. Thank you for so much for this week 14. We finished, so we will continue in the next slide. Thank you.